Hello students, in today's class we will see about steady state error. Okay, so before going into steady state error we have to get a transfer function for the error. Okay, so this is a general block diagram where of a feedback control system. RFS is the input, this is a summer, and this summer finds the difference between the input signal RFS and the partially fed back signal, right? And the difference is nothing but E of S error, and the error is given to G of S, and based on the error the G of S gives output C of S. Okay, so for this block diagram, what is E of S? We know that E of S is nothing but R of S minus, see what is this? This is nothing but R of S minus, this is C of S into H of S, right? Now what is the C of S? C of S is equal to E of S into G of S, right? So now what is E of S? E of S is nothing but R of S minus E of S, G of S, H of S, right? So taking E of S signal to one side, what will happen? R of S is equal to E of S plus E of S, G of S, H of S. So taking E of S common, what do we have? 1 plus G of S, H of S, right? So what is E of S? So E of S is equal to R of S divided by 1 plus G of S, H of S. Okay, so this is the error. See, what is the steady state error? Steady state error is the final value of the error when t tends to infinity. Okay, so steady state error ESS is given by limit t tends to infinity E of t. Okay, in other words, if it is given, if the error is given in terms of S domain Laplace, then the steady state error ESS is equal to limit S tends to 0 S into E of S. Okay. So this is how we find out the steady state error, right? How the steady state error varies with respect to the different standard inputs, step, ramp and parabolic. We will see now. Okay, so let us assume a step input. So for a step input, unit step, okay, unit step input. Unit step input R of S is equal to 1 by S, right? See, this steady state error depends only on the two factors. One is the input R of S and the other one is the transfer function, which is open loop transfer function. Open loop transfer function, and this is G of S, H of S. Okay, so the steady state error depends only on these two factors, input and open loop transfer function. So let us first assume the different standard inputs. So first is the unit step input, R of S is equal to 1 by S. So what will happen if it is unit step? Our E of S will become, okay, E of S is equal to, what is R of S? 1 by S divided by 1 plus G of S, H of S, right? But we know that steady state error is nothing but limit S tends to 0, S into E of S. So which means limit S tends to 0, S into 1 by S, the whole divided by 1 plus G of S, H of S. So what happens? These S terms gets cancelled, right? So the steady state error is given by limit S tends to 0, 1 divided by 1 plus G of S, H of S. Okay. So what will happen when you apply the limits now? This 1 and this 1 remains as it is, but this G of S, H of S is in terms of S. So when you substitute S tends to 0, the value may vary depending on what the open loop transfer function is, right? So let us assume that to be a constant. So which is nothing but 1 by 1 plus Kp. Now what is Kp? Kp is equal to limit S tends to 0, G of S, H of S. And this Kp is called positional error constant. Okay, Kp is called as positional error constant. So this is the steady state error for a unit step input. Okay, what is the error constant for a unit ramp input? Unit ramp. So when you take unit ramp, we know that R of S is equal to 1 by S square, right? So what happens? E of S is equal to 1 by S square divided by 1 plus G of S, H of S. So what is the steady state error? ESS is equal to limit S tends to 0, S into E of S, which is nothing but S into limit S tends to 0, S into 1 by S square, the whole divided by 1 plus G of S, H of S. Single S term will get cancelled. So what do we get? We will have ESS is equal to limit S tends to 0, 1 divided by S plus S into G of S, H of S, right? This S term comes down. So what happens when you apply the limits S tends to 0, this becomes 0 and this S G of S, H of S is not known because we don't know what is the open loop transfer function, right? See, so what happens? This is nothing but 1 by Kv. Okay, velocity error constant, where Kv is nothing but limit S tends to 0, S into G of S, H of S. Okay, so similarly when you go for parabolic input, what happens is unit parabolic. So when you apply parabolic, R of S is given by 1 by S cube, and similarly when you apply the limits ESS is equal to limit S tends to 0, S into 1 by S cube divided by 1 plus G of S, H of S, and finally this is nothing but 1 by Ka you will get, where Ka is equal to limit S tends to 0, S square, G of S, H of S. Same as that of this one. Okay, because 1s will get cancelled and you will be getting 1 by S square plus S square G of S, H of S. Again when you apply the limits, S square will become 0 and this S square G of S, H of S is not known. So that is replaced by Ka. Okay. So this is what is the steady state error.